Visible from space, as this satellite image shows, phytoplankton form enormous green swirls hundreds of miles long around coastal waters, which are rich in the nutrients these plants need to live on. They use photosynthesis to absorb sunlight, as well as carbon dioxide from seawater.
Just like trees, they take the carbon dioxide and give us back oxygen. These phytoplankton, these amazing little plants, may be holding the key to saving the planet.
Ian Jones believes that by adding nutrients to areas of the ocean that lack phytoplankton, he can turn them into a lush forest that will reverse the effects of global warming by absorbing carbon dioxide. In 1995, a team of American oceanographers set out to study the desolate zone. That's an area 250 miles to the southwest of the Galapagos Islands, where there is little phytoplankton. They wanted to find out what was making the desolate zone so desolate. The theory? That it was missing a vital nutrient, iron. So half a ton of iron was added to the sea. Ken Cole was one of the scientists on board and witnessed what happened next.
Results from the Iron X2 near the Galapagos were dramatic and turned the ocean green for miles. There were scientists that would walk out and look at this green ocean and burst into tears at the dramatic way in which a small amount of iron would have such a huge effect on a community. And this was sort of like discovering, the key to climate change.
When CO2 is absorbed by phytoplankton, it releases oxygen, with the remaining carbon staying in the plankton. When the plankton die, they sink to the deep ocean floor, taking the carbon with them. By the end of the expedition, the scientists had calculated that this small area of phytoplankton had absorbed an additional 7,000 tons of CO2, the equivalent to over 2,000 fully grown redwood trees. But back in Australia, Ian Jones is convinced that his plan to use nitrogen-rich urea will have a wider use than iron. Only 20% of the oceans, like the desolate zone, need iron to grow more phytoplankton. Nitrogen would act as a more general booster in a whopping 80% of the oceans, so Jones thinks that his idea would be more effective. But Ian Jones's idea of making the oceans bloom by boosting them with nitrogen may have a very serious downside. Fish have died where there is an excess of phytoplankton, but Ian Jones thinks he can control the phytoplankton at levels that won't kill marine life. So his plan will only work where there is not much phytoplankton to begin with.
The important about ocean nourishment is we're not doing it where there's lots of productivity, we're doing it in the desert regions of the ocean.
If you don't like the outcome of ocean nourishment, of course, you can just turn off the tap. This is like irrigating the desert. If you irrigate the desert, the plants bloom, but if you turn off the water, they just die and go away. The same thing will happen in the ocean. When you turn off the food supply for the plankton, they'll just die and fall to the deep ocean.
The benefit of urea as a successful fertilizer is evident on most agricultural land. It is rich in nitrogen, used by farmers to fertilize their crops. So Ian Jones has turned to an agricultural solution to produce his nitrogen in a form that can be added to the ocean: urea granules. He's met up with environmental scientist John Ridley at this fertilizer factory.
Nitrogen's a very common element in the atmosphere. About 80% of the atmosphere is nitrogen and about 20% is oxygen. So nitrogen is readily available. It's just not in the form that we can use for nourishing the oceans.
The nitrogen, fixed in urea granules, should be easy to transfer and dissolve in seawater. But should we be meddling with an ecosystem that's taken millions of years to evolve?
We've changed the planet, and once you start managing nature, you have to continue to manage nature. There's no use hoping that it'll restore itself to a new equilibrium set up by humans. Nature will need to be managed forever now that we've changed it dramatically.